Okay students, now we will see the next molecule, that is nitrogen molecules. Now what happens students, nitrogen molecules, when the two atom of nitrogen, atomic orbitals of nitrogen atom combines, they will form the molecular orbitals. Now if you want to draw the diagram of molecular orbital of nitrogen molecule students, first you know the electronic configuration of nitrogen atom. What is the atomic number of nitrogen? 7. Electronic configuration students, 1s2, 2s2 and 2p3. This is the electronic configuration. This is the electronic configuration of nitrogen atom. Now students, when the atomic orbitals of nitrogen atom, two atomic orbitals students, atomic orbitals of nitrogen atoms, they are combining. So first we will draw the energy level of atomic orbitals of nitrogen. So students, here we will see one electronic configuration, 1s2. Suppose we are writing the energy level of 1s2 will be 1s orbital will be like this. 2s energy level of 2s atomic orbitals will be present here, and 2p energy of 2p orbitals. This is 1s orbital having 2 electrons, 2s orbitals having 2 electrons, and 2p orbitals 3 electrons. So 1s2, 2s2, 2p3. Same thing students, because it is same atom, so energy level will be mostly equal like this. So this is 1s2, 2s2, which is similar to 2s2, and 2p3. Now students, because 1s having only one orbit, so we are drawing one orbit like this. 2s is also having only one cell, and 2p is having what? 3 subcells which are very close to each other. That means their energy are similar. Okay students, same thing is happening here also. 1s, 2s and 2p. P orbital is having px, py and pz. Okay students, now we are going to distribute the electrons of atomic orbitals. Now 1s2, that means 2 electrons we are going to, 2s2, 2 electrons will be paired like this. 2p3 students, 1 electrons we are going to put like this. Same thing is happening in this nitrogen atom also. 1s2, 2s2 and 2p3. Okay students, now what happens students, when these atomic orbitals overlap and they will form the bonding and anti-bonding molecular orbitals. Now we are going to draw the molecular orbitals of N2 molecule. Okay students, so what happens students, it will form bonding and anti-bonding. So bonding atomic orbitals having lower energy than the anti-bonding atomic orbitals. Okay students, this is the bonding which having a lower energy than atomic orbitals. This is the molecular orbitals. So students, when they will combine, when they will overlap these atomic orbitals, they will form the sigma 1s, and they will form anti-bonding, that is sigma star 1s. So students, they are originating from these two atomic orbitals. So this way you have to draw the diagram. So this is the overlap of 1s orbitals. They will form the sigma 1s and sigma star, that is anti-bonding. This is bonding and this is what? Anti-bonding orbitals. Okay students, molecular orbitals. Now here also, now how you are going to distribute the electrons, because here 2 electrons, so 1 electrons, total 4 electrons we are going to distribute in bonding and anti-bonding. Same thing is happening here also students. When 2s orbitals are coming, they will form the lower energy will be bonding, and they will be what? Anti-bonding molecular orbitals. Okay students, so here 4 electrons you have to distribute like this. They will form sigma 2s and it will form sigma star 2s molecular orbitals. Now what happens students, when 2p orbitals combine, they will form the 2 bonding molecular orbitals and 2 anti-bonding molecular orbitals. Okay students, so because they are coming from these 2 p atomic orbitals, you can draw the diagram like this. Molecular diagram you have to draw like this. These are also originating from these atomic orbitals, because total how many? 6 atomic orbitals are there students. So 3 will occupy in the bonding, they will occupy like this, and 1 will be and 3 will be in anti-bonding molecular orbitals. Here students, these two are pi, because these two are 2px and 2pi. So the bond molecular which are the bond which is forming that we call as pi 2px and pi 2py, and here it is formed when px, py or pz orbitals, they will form the sigma 2pz. These are the bonding molecular orbitals, students. Their corresponding anti-bonding molecular orbitals will be pi star 2px and pi star 2py, and the sigma 2pz, its corresponding anti-bonding molecular orbital will be sigma star 2pz. Okay students, now here we have 6 electrons. So 6 electrons, all the electrons first they are going to fill the bonding molecular orbitals and they will start pairing like this. Okay students, so when you see students, this is the molecular orbital diagram of nitrogen molecules. Okay students, now when you write down the electronic configuration of nitrogen molecules, so here the electrons are distributed like this. Okay students, so electronic configuration of nitrogen molecule will be, this is the sigma 1s2, you have to put the comma, sigma 1s2, sigma star 1s2, 2 electrons are present in anti-bonding. Now again sigma comma sigma 2s2, sigma star 2s2. Now here students, pi, because these molecular orbitals are present in same line, so the energy levels are equal. Mostly they have what? Equal energy level. So you can put like this, pi 2px pi 2py, and then you write sigma 2pz2. This is the electronic configuration of nitrogen molecule. Now students, when you are talking about the bond order of these nitrogen molecules, so we have the formula for finding the bond order. The number of electrons present in bonding, B stands for bonding, number of electrons present in bonding molecular orbitals minus number of electrons present in anti-bonding, and we have to make it half. So students, number of electrons present in bonding means these are the having the low energy, so these are the electrons which are present in bonding. So when you count all the electrons students, you will find 1 2 3 4 5 6 7 8 9 10 electrons are present in bonding. 10 minus the electrons which are present in anti-bonding students, 1 2 3 4, only 4 electrons which are present in anti-bonding molecular orbitals, and we have to make it half. So you will get students how much? 3. That means nitrogen triple bond will be present. Understanding? So this is the bond order in nitrogen molecule. Now when you see the magnetic property students, so see the students, there is no unpaired electron. That means it is not a paramagnetic. All the electrons are paired in the molecular orbitals. So it is what? It is diamagnetic in nature. We call as they are diamagnetic. They are diamagnetic. The molecule is what? Diamagnetic in nature. So this is about the nitrogen molecule students. Now next molecule we are going to see students, oxygen molecule. If you want to explain the electronic configuration of oxygen molecule, bond order and magnetic property students, you should know the molecular orbital diagram of oxygen molecules. Okay students, so same thing is happening students. You should know the first of all you should know the atomic number of oxygen atom. Atomic number of oxygen is 8. What is the atomic number of oxygen students? That is 8. Electronic configuration students, electronic configuration of this oxygen, 1s2, 2s2 and 2p4. So 8 protons, we can neutralize 8 electrons. Okay students, now what happens students? Oxygen molecules, atomic orbitals, these are the atomic orbitals of oxygen atom. Now one more atomic orbitals of oxygen atoms, and they will combine, they will form the molecular orbitals of oxygen molecule. So students, here we are going to draw the molecular atomic orbitals, energy level of atomic orbitals. So 1s is having what? Lower energy. So we are going to make the line over here. This is the 1s orbital, and after that students, you have got what? 2s, and then you have got 2p. The electrons which are present students, 1s2, 2s2 and 2p4. 1s having only 1 atomic orbitals, 2s is also having 1 atomic orbitals, 2p is having 3 atomic orbitals. That means it has 3 subcell. Okay students, Same thing students, because same oxygen atom is the energy level of this atomic orbital will be similar like this. So this is 1s2, 2s2 and 2p4. One orbit, it is also having one orbit, and 2p, that is p orbital, has what? 3 subcell. Now students, we are going to distribute the electrons in the atomic orbital of oxygen atom. So 1s2, that means 2 electrons. 2s2, 2 electrons will be paired like that. 2p4, 1 electrons. First we have to put in all the subcell, then the pairing will start. Same thing is happening here also students. 1s2, 2s2, 2p4, 1 electron each, and then the pairing. Okay students, now this is the atomic orbitals I have drawn. Now students, we are going to draw the molecular orbitals. So students, when the atomic orbitals combine, number of molecular orbitals form. Now here 2 atomic orbitals combined, they will form the 2 molecular orbitals. One molecular orbital will has lower energy and one will having what? Higher energy. The higher energy we called as what? Anti-bonding. That is, it is forming the bond. That bond is called as sigma 1s, and it is forming what? Sigma star 1s. So this way, because they are originating from these atomic orbitals, so we have to make the line, dotted line like this. Same things happening here also students. The 2s atomic orbitals combine and they will form the 2 molecular orbitals. So this is sigma 2s and this is what? Sigma star 2s. Okay students, so this way they will form the molecular orbitals. Now here students, total 6 atomic orbitals are there. They will form the 6 molecular orbitals. Out of 6 molecular orbitals students, 3 will be having the lower energy and 3 will be having higher energy with respect to atomic orbitals of p. So out of 6 students, 3 atomic orbitals we are going to draw, that is they are present bonding, having lower energy, and 3 will have higher energy. Okay students, this is they are originating from these 2p orbitals. Now what happens students, now we are going to distribute the electronic configuration of oxygen molecule. Now here total students, we have 4 electrons, 1s2 and 1s2. So 4 electrons are distributed like this. First it will go to the bonding, then it will go anti-bonding. Here also students, 2s atomic orbitals of oxygen atoms combined, they will form the 4 electrons are there. So 2 electron will go to the bonding and 2 electron will go to the anti-bonding. Here students, total 8 electrons you have. So students, how you are going to distribute the 8 electron students? First, out of 8 electron students, 6 electron will go to the bonding molecular orbitals like this. Now 2 electrons will go to the anti-bonding. There will be 1 electrons. So this way students, you can write the electronic configuration. Once you fill the electrons, what will be the electronic configuration of oxygen molecule students? So first will be, here also you can put students 2p. So here you have pi 2px and pi 2py. Here you have sigma 2pz, and it will form its corresponding anti-orbital will be sigma star 2pz. Its corresponding anti-bonding students, pi star 2px and pi star 2py. Now we are going to write the electronic configuration of oxygen molecule. So first students, sigma 1s2. Here students, in sigma 1s2 comma, then sigma star 1s2, then sigma 2s, sigma 2s2, sigma star 2s2, then students pi 2px, which are having equal energy, so pi 2py2. Then we have students pi star 2px and pi star 2py, 1 electrons. So students, when you write down the bond order now, so bond order is equals to students, number of electron present in bonding minus number of electron present in anti-bonding, and you have to make it half. So when you count the number of electron present in bonding students, you will find total students 1 2 3 4 5 6 7 8 9 10 electrons are there. 1 2 anti-bonding, 1 2 3 4 5 6 electrons are present in anti-bonding molecular orbitals, and make it half. So you are getting students 4/2, that is 2. That means oxygen molecules is having double bond. Okay students, the bond order is what? Like this. Now when you see the magnetic properties, see the molecular orbital students, here 2 unpaired electron, that means it is a paramagnetic. If it is unpaired electron, we call as what? Paramagnetic in nature. It is a paramagnetic. So oxygen molecule is what? Paramagnetic in nature. So this way, students, we can write down the electronic configuration, bond order, and magnetic properties of oxygen molecule. Now, students, next molecule we are going to see, that is fluorine molecule. In fluorine molecule, students, you should know the atomic electronic configuration of fluorine first. Electronic configuration of fluorine atom. Atomic number of fluorine is, students, how much? It is 9. Its electronic configuration will be 1s2, 2s2, and 2p5. What happens, students, when it will form fluorine molecule? The atomic orbitals of fluorine atom combines. Two atomic orbitals of fluorine atom combines, and they will form the molecular orbitals of fluorine F2 molecule. Now what happens, students? Now we are going to draw the energy level of atomic orbitals of fluorine atom. So this is the 1s2. Now we have 2s2. Then we have what? 2p5. Same thing is here also, students. Energy levels will be equal. 1s2. Then you have 2s2. Then you have 2p5. Now 1s2 having one subcell and 2 electrons, we have to fill up like this. 2s is also having one atomic orbitals, so they will fill like this, 2 electrons. Now students, 2p having 2px, 2py, and 2pz. It is 3 subcell. These atomic orbitals having 3 subcells. Now 5 electrons will be distributed first singly, then the pairing will take place. Same thing is happening in these molecule, students. In these atomic orbitals, 1s2, 2s2, and 2p5 will be like this, students. 1 electrons, then the pairing will take place. Now students, when these 2 atomic orbitals 1s2 combines, they will form the bond 2 molecular orbitals. One will have higher energy than these atomic orbitals, and one molecular orbital will have what? Lower energy. Okay, students. So which the atomic molecular orbitals have lower energy, we call as bonding molecular orbitals, because it is made up of 1s, so we call it as a sigma 1s atomic orbitals, and this having higher energy, students, we call it as sigma star 1s. Now students, because they are originating from this 1s, students, we have to make the dotted line like this. Now we are going to distribute 4 electrons in this. What happens, students? It will form the first 2 electrons will go to the bonding, then it will go to the anti-bonding molecular orbital. Same thing is happening here, students. When 2 atomic orbitals of fluorine atoms combine, they will form the 2 molecular orbitals. One will be the bonding and other will be what? Anti-bonding. Okay, students. Now here also, students, because they are coming from these atomic orbitals, so we have to put the dotted line, and the bond which is formed, students, we call as sigma 2s, and here it is anti-bonding, students, sigma star 2s. Now 4 electrons, students, out of 4 electrons, first 2 electrons will go to the bonding, then it will go to the anti-bonding. Now what happens, students? 2p orbitals, when they will combine, students, the 6 atomic orbitals combined, they will form the 6 molecular orbitals. Out of 6 molecular orbitals, students, 3 molecular orbitals will have lower energy, and 3 will have what? Higher energy. So these atomic orbitals combined, they form the molecular orbitals. So this is the sigma. This is sigma 2pz, and this is a pi 2py and 2 pi, which is equals to pi 2px. All are having what? Same energy level. So its corresponding anti-bonding molecular orbital will be pi star 2px, which is equals to pi star 2py, and the sigma 2pz atomic orbital, its corresponding anti-bonding molecular orbital will be sigma star 2pz. So because they are coming from these 2 atomic orbitals, so we have to put the dotted line like this. Okay, students. Now we are going to fill 10 electrons. 6 electrons will go to the bonding molecular orbitals, and remaining 4 electrons will go to the anti-bonding molecular orbitals. First the one electron, then the pairing will take place. Now students, we are writing the electronic configuration of fluorine molecules. Now we have already filled the electrons. Now we will write down the electronic configuration of fluorine molecule, that is molecular electronic configuration of fluorine molecules. So first is, students, sigma 1s2, because 2 electrons, then comma sigma star 1s2, then sigma 2s2, sigma star 2s2, then we have sigma 2pz2, then we have, students, pi 2py2, because they are having energy level is same, we can write equal sign 2p x. Then we have students anti-bonding molecular orbitals, pi star 2p x 2. Then we have pi star 2p y 2. Now students, this is the electronic configuration of fluorine molecules. Now bond order students, how we are going to calculate the bond order? The number of electrons present in bonding molecular orbitals minus number of electrons present in anti-bonding molecular orbitals, and you have to make it half. So students, when you count the number of electrons present in bonding students, so 1 2 3 4 5 6 7 8 9 10 electrons are present in bonding molecular orbitals. 10 electrons are present, and non-bonding electrons are students 1 2 3 4 5 6 7 8 electrons present in anti-bonding. You can make it half, so 2 minus upon 2, that is 1. That means fluorine there will be single bond. Okay students, when you see the magnetic property, because all the electrons are paired, so it is what? Diamagnetic in nature. It is diamagnetic. So it is a diamagnetic in nature. This is all about the fluorine molecules. Now students, one more simple molecules we are going to see, that is helium molecules. So here also students, you know the atomic number of helium is 2, electronic configuration is 1s2. So electronic configuration of helium atom. Now students, here also students, we are writing the atomic orbitals of helium atom, because it is only one atomic orbital, students, one orbitals, and it is also having the one atomic orbitals. So 1s2 atomic orbitals of helium, they will combine and they will form the, when two atomic orbitals of helium atoms combine, they will form the two molecular orbitals of helium molecule. Now one will be the bonding and other will be what? Anti-bonding. So this is sigma 1s, and this is what? Sigma star 1s atomic molecular orbitals of, because they are coming from the 1s, so we can put the this dotted line, they are originating from this. Now 1s2 atomic orbitals, 2 electrons are there, here is also 2 electrons, and they will form the molecular orbitals. Now students, our 4 electrons, how we are going to distribute? So first it will 2 electron will go to the bonding molecular orbitals, and then remaining 2 will go to the anti-bonding. Now students, what will be the electronic configuration of helium? Now when you want to write the configuration helium, to sigma 1s2 sigma star 1s2. Now when you write down the bond order students, bond order, how we are writing? Number of electrons present in bonding molecular orbitals minus number of electrons present in anti-bonding molecular orbitals, and you have to make it half. That means 2 minus 2. Okay students, 2 electrons are present, so 0 upon 2, that is 0. There is no bond in the helium, so that means helium is what? Monoatomic. It is monoatomic molecules. There is no bond. Understanding students? So, and when you see the magnetic property, it is what? Because all the molecular orbitals are paired, so it is diamagnetic in nature. Diamagnetic in nature. So this is all about helium molecules. Now one more molecule students we are going to see, that is the carbon monoxide molecule, because it is made up of carbon and oxygen. Carbon atomic number is students, carbon atomic number is 6, electronic configuration 1s2 2s2 and 2p2. Oxygen atomic number is students 8, electronic configuration 1s2 2s2 and 2p4. Because of oxygen is more electronegative than the carbon, so its energy level will be lower than the carbon. So students, when you write down the atomic orbitals of carbon atom and atomic orbitals of oxygen atom, because of the oxygen is what? More electronegative than the carbon, so atomic energy of the oxygen will be what? Atomic orbitals of the oxygen atom is having one lower energy than the carbon. So energy level of carbon students, I am drawing 1s2 2s2 and this is what? 2p2. So because of the energy level of electronegative of oxygen is more than the carbon, so energy level of this will be always lower than this carbon. So this is the 1s2 2s2 and this is what? 2p4. Now students, we are filling the electrons, 2p having what? 3 subshell. Here also students 2p2 1 electrons. Here students 1s2 2s2 and 2p is having what 4 electrons, so 1 electrons, then the pairing will take place. Now what happens students, the molecular orbitals having lower energy which form the bonding, it is having lower energy than the atomic orbitals. So this is sigma 1s, so this will be the sigma star 1s. Okay students, so because the molecular orbitals diagram will be like this. Same way here also students, this is sigma 2s, so this will be what sigma star 2s. Okay students, now we are the same way, when these atomic orbitals combine they will form the 6 molecular orbitals. 3 will be like this, because they are coming from these atomic orbitals we can put the dotted line like this, and its corresponding anti-bonding orbitals like this. This is sigma 2pz, so its corresponding atomic anti-bonding molecule sigma star 2pz. If it is pi 2px, which is equal to pi 2py, so its corresponding anti-bonding molecular orbital pi star 2px, which is equals to pi star 2py. Now students, we are going to put the electrons molecule. This is the molecular orbital of diagram of carbon monoxide molecule. Now here students, 4 electrons you have to distribute like this. 2 will be the bonding and 2 will be the anti-bonding. Same thing is happening in sigma 2 star, sigma 2s2 and sigma star 2s2. 6 here total. How many electrons you have students? 4 from oxygen and 2 from carbon. Total 6 electrons we are going to distribute. So 6 electrons will be distributed in the bonding molecular orbitals only. All the electrons will go to the bonding. There is no electron present in the non-bonding molecular orbitals of carbon monoxide. So electronic configuration students, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px2, pi 2py2, and this is the electron, because these two orbitals are having the equal energy. Now bond order students, number of electron present in bonding at molecular orbitals minus number of electron present in anti-bonding, and you have to make it half. So when you count the number of electron students in bonding, 1 2 3 4 5 6 7 8 9 10 electrons present in bonding. In anti-bonding students you have 1 2 3 4 electrons. So you will got students carbon and carbon oxygen, there is a what triple bonded molecule. So this way you can write down the bond order of carbon monoxide students. Magnetic properties, there is no unpaired electrons, so they all are what, it is a diamagnetic in nature. It is diamagnetic in nature. So this way students we can explain the heteronuclear atomic molecules also. You can write down the molecular diagram of heteronuclear, because different atomic orbitals of different atoms. This is carbon, this is oxygen. That is why we call as what heteronuclear. So students, these are very important for the examination point of view, for your competitive examination also. If you like my video, please share it, subscribe it. Thank you very much.